Welcome to the Project Highway Zero Repairing Roads the Right Way discussion panel event. Today we'll explore the hot or cold debate when it comes to road repair. We've got 4 industry experts joining us, and each will have 3 minutes to present their case on a series of 4 questions, and this will be followed by a 5-minute open debate on each question. So without any further delay, we'll meet our panellists and allow them to introduce themselves. First, Hassan Nageim, Professor of Structural and Pavement Engineering at Liverpool John Moores University.
Thank you very much, Chairman. Good morning, everybody. May I take this opportunity to thank Russell and Neil at Meon for giving me this opportunity to join this event, very, very important event, and also certainly I learned yesterday from the trial and the demonstration they have done. So it seemed to me the event is very, very well prepared. My name, as I mentioned, is Professor Hassan Nageim. I did my BSc from University of Baghdad, Iraq. My MSc is from University College Cardiff. The PHD is from Heriot-Watt University. I have more than 25 years at LJMU. Currently, I am the head of the novel and bio-based technology. The research team included 13 staff, plus 2 professors, one of them from chemistry and the other one is from material microscopy sciences. I published over 170 journal papers and conference paper, invited as a speaker as well as a chairman to many national and international conferences. I'm external examiner to many universities, including Nottingham University, Liverpool University, Salford, Portsmouth, you name it. And also I'm expert on structural and pavement engineering, editor-in-chief of the International Journal of Pavement Engineering and Asphalt Technology, and the founder and the chairman of the International Conference on Highways, Road and Infrastructure. Thank you.
Thank you. And to Hassan's left, we've got Karl, Chief Engineer Civils at Telent.
Good morning, and thank you very much for inviting me. I'm really looking forward to this debate. So my background is I've spent approximately 44 years in engineering. The first 16 of those were with the Royal Engineers, working on projects around the world. Since 1994, I've been involved with working for the UK utility sector. Unusually, I've covered most of the sectors, so I've worked in gas, water, electric and telecoms. I've had a variety of roles, including UK reinstatement manager at Morgan Sindall's, sustainability manager at Balfour Beatty Utilities. I was head of streetworks at Carillion before their demise, and currently I'm the civils chief engineer at a company called Telent, who predominantly do telecommunications work. I also run my own small consultancy company part-time, and have recently worked on the development of a new range of low-carbon mastic repair products. I've worked closely in the past with Liverpool John Moores on several research projects looking into bituminous materials and their performance. I'm also a member of the SROH Expert Practitioners Group and help out with the SROR, which is the Scottish version of the SROH, on their A9 approvals group.
Thank you. On the other side of the panel, we've got Barry Andrews, the technical lead at SHIMPAC Systems.
Matt, thank you very much. Meon, thank you for inviting me to this debate on repairing roads the right way. My name is Barry Andrews and I work for a materials supplier, SHIMPAC Systems. So we supply materials to the highways industry. So why would I suddenly be considered an expert? Well, my background is with National Highways, where I was a senior project manager on both construction and then maintenance contracts, and then latterly responsible for the contents, the publishing, and the restructuring of their technical literature in the form of the Design Manual for Roads and Bridges and the Manual for Contracts for Highways Works. The importance to the industry there is that these are the governing documentation sets, not just for the UK, but they have in many of their forms been adopted across Europe. So for myself, I understand many of the problems that are faced by the highways industry, particularly in the interpretation of the text and the customer and construction materials requirements. So for me, performance and longevity are keywords. Certainly for industry, they are becoming more of the norm, and that's how contractors are actually judged. So I bring the industry knowledge of the European and UK technical guidance, particularly those that are governing the restatement of ironworks. So that's very important for me. I've been involved in both the content from a practical point of view, but also in the authoring, restructuring and publishing perspectives. So hopefully for today's debate, I'll be able to offer another view of what we're faced by.
Thank you. And last but not least, Russell Smallridge, Head of Decarbonisation at Meon.
Thanks very much, Matt, and thanks to the panelists. So thanks to Karl, thanks to Hassan, thanks to Barry for joining us today. So background for myself, I started off my career in the construction industry, then moved into the environmental spill control of a company called LoopTech. Spent 10 years developing some revolutionary spill control products and systems. Joined Meon in 2013, heading up the supply chain team. That included and evolved into work on research and development, road trials, and more latterly in the last 2 years been focused on the decarbonisation of highway strategy, which we've embraced in our Project Highway Zero campaign, and we have launched the 3 principles Project Highway Zero model. That includes repairing roads the right way, elevating standards of the cycleway schemes, and transforming road marking for good. Today we're going to be focused on repairing roads the right way, and back to you, Matt. Thank you.
Appreciate it. Appreciate you all introducing yourselves. So if we get into it, we've got 4 questions that our experts will discuss and debate. So question 1, can effective highways repairs only be achieved with hot works materials? And I think we'll start with Hassan.
Thank you very much for this question. Basically, we need to here define the hot work materials. If we are talking about hot mixed asphalt, we need to see whether we are talking about the normal hot mixed asphalt, which we normally use for road surfacing, and the temperature range is usually more than 130 centigrade. It's a bit more than this one, 140 to 170. There are a lot of material which is produced, since the technology of the road surfacing started using hot mixed materials, and we have now the warm mix, and we have the other materials which is highly developed. So the answer, if the repair place is being constructed and the material being laid, hot, to the specification, compacted to the specification, the answer is yes. The hot mixed asphalt is a good material for that. But the cold mixed asphalt, since 1957, that's the approximate time at the USA, the cold mix material produced, and the people tried to use the material, and they found that it needs a curing time of 2 months to 24 months. Since then, the material went through a lot of development, and today, especially at Liverpool John Moores University, we managed to reduce the curing time to less than 1 day. Also, work has been done at Germany and France. They replaced the limestone filler with OPC, and the OPC is, as you know, ordinary Portland cement, and that's material. Every 1 ton of the OPC need produce 1 ton of the CO2 emissions, so it's not a friendly, environmentally friendly material. Now the material which is now used on road, and they are called materials, some of them work, some of them is not, so therefore a lot of work is really required at laboratory, research center, as well as in companies for these materials to be developed further, and also prepared, the site prepared and laid, compacted to the specification. There are a lot of problem with the checking these materials, especially if you are using the SROH, simply because of the condition of the roads as well as the material during its lay, and we will cover this one later. Thank you very much.
Thank you. We'll stay on that side of the panel. Karl?
Okay, so effective highway repairs only achievable with hot work material. So, is it just that simple? Everything and anything to do with the roads is never quite that simple. So, hot mix material. So, there are lots of different versions of hot mix materials apart from the individual grades and mixes. We've got standard mixes. The utilities have an enhanced mix which has got slightly more bitumen in it to make it easier to lay and to compact. We've got now coming in quite fast warm mix materials. Warm mix materials are relatively new, particularly to smaller operators. The big operators have been working with them for some time. And then at the far end of the scale, you've got materials that can be mixed, batch mixed on site and don't require compaction. So you've got the flowable mastics. If we go to cold lay, so what do we mean by cold lay? So there's 4 basic types of cold lay. You've got emulsion, which is a water-based. You've got a solvent-based one, which as you compact it, evaporates out. There's a cementitious one, which actually works brilliantly in water. And then you've got the MMA materials. Each one of those has its own characteristics. Each one of those has its place, and each one of those will have a time frame that it will last. The more expensive materials last much longer, and it's a balance, in my opinion, between the size of the excavations that you're working on, is there a tarmac plant nearby, how far have you got to transport it, how long is it going to be in the vehicle, how much do you actually need, if you're going to buy a ton, do you need a ton, and the whole life cost, not only in monetary terms but in environmental terms, of using a superior material can actually reduce your costs and reduce your emissions. So, not a simple answer. There's a place for all of it, in my opinion, depending on the scale of the works that you're doing.
Thank you. We'll come across the barrier then on that one.
Matt, thank you so much. For the debate on whether effective highway repairs can only be achieved using hot mix materials, the door is ajar. I think that's the best way we can say it. You've just heard from Karl that there are many characteristics associated with the cold mixes that give us advantages when it comes to looking at the scale and size of the repair requirements. So, whilst we can understand that these materials are proven in situ, it does mean that each use has to be assessed from each company's own perspective. So there might be contract-led, there might be requirements that are actually legislative. But for the majority of uses, in my opinion, the cold mix does offer some great advantages. So what we have are safety considerations. Cold mix can be laid without the need for heated and bitumen warmers. The technology is proven, so the market can gain advantages from knowing that the materials meet the performances as stated, and that can be demonstrated too. We know that actually, particularly now when we're looking at sort of budgets and sort of local authority spending and utility costs, then money-saving initiatives will always sort of percolate to the top in anyone's consideration, particularly around budgets. So cold mix again offers great advantages over the hot mix materials. Whilst there has always been a proven benefit for laying hot mixes, that is scale. So much larger sort of repairs are undertaken using hot mix, and as Karl alluded to, then we've now introduced warm mixes. But for the small scale utility considerations where there are reinstatement works or immediate emergency repairs, then cold mixes definitely have their place. And it is therefore the consideration of the phrase effective repair that opens up the debate to everybody. So I think at that point I'll hand back to you, Matt.
Well, I'll push it straight on to Russell and just ask for your thoughts.
Yeah, no, thanks very much, Matt. I suppose let's go back to John Loudon Macadam, born in 1756. So he pioneered the construction of roads in Great Britain, unrivaled since the Roman times. And then moving on to 1902, when Egbert Pernell Hooley, he pioneered the introduction of asphalt and tar with steel slag, and we started to see the asphalt paving coming into this country. What we have to understand here is, as a nation, as an industry, we know and love hot works. We know and love the hot asphalt material. But is it the only way that we can repair our roads? And the answer is very simple, in my view, is no. There are multiple, as Karl's already explained, multiple different cold applied systems that are effective. They can actually outperform some of the hot applied materials and systems that are out there. And they should definitely have a place in the industry, and they do have a place in the industry, and they should be something which we can develop and investigate further and embrace. So back to you, Matt, really. I think
Well, I guess that brings us into a debate, doesn't it? First 5-minute debate. So if we're saying that hot and cold solutions are both potentially viable, how important is it that we look at the safety, at the cost, when we're making that decision? Who wants to take a lead on that?
So I think cost-wise, industry will lead that. You can't force somebody into accepting something. There's, having worked in utilities for most of my engineering life, cost is a huge thing. The thing with cost, though, is getting over to people that paying a little bit more is actually, in most cases, cheaper. So buying something which is a better material that performs better in the long run, or the whole life cost of the reinstatement actually comes down, because any reinstatement that doesn't last for its guarantee period is hugely expensive to go back to, and a massive waste of time and effort and environmental resources. So yeah, it's a learning thing for people to get over that sometimes things that are slightly more expensive are actually cheaper.
How do you think you tackle that education then, convincing someone that spending a little bit more is actually cheaper?
Well, I'll take this one. So for ourselves, we were debating about effective repairs, and as Karl's explained, if effectiveness means that everybody understands why, and that it lasts for a great length of time, then it makes common sense that actually within the industry we spend some of our time, some of our resource educating and training the engineers and the operatives that we have working for us, in getting them to understand what materials are out there, the actual practices, the benefits that are provided. That's not just engineering professionals that benefit from this, because then you start looking at your budget managers, your financial institutions, you look at the material suppliers. They understand actually what the characteristics are of the products, and then can help and advise and inform, which is again a benefit to our whole industry. So whilst I come from a background of the written word where we explore what our policies are and why we need to have these things in place, the true benefit to our industry is through education, and that is not just education on how to do the job. That is education of the benefits that these other alternatives will offer our industry in the years to come. So if you then match that with your key performance indicators and your sustainabilities, we are going to open up another field for debate.
Does anybody find on that effort to educate that sometimes you face the sort of, well, this is just how we've always done it approach? And if so, how do you get past that?
I think, if we take, the word innovation, invention, innovation, and collaboration. What I mean by collaboration here, the people who are making the policy, the people who are implementing the repairs, and also the councils. These people meet, together, and they understand, the situation. Definitely, cold mix asphalt repair has many advantages. One of them is the health and safety. CO2 emission will be less. And also, if the cost is very acceptable, then the whole life cycle analysis will be a benefit as well. And so that means, if we looking into the material itself, and do the link, between the invention, the innovation, and also the collaboration, we will meet, will come with the system to the repairing, whereby we can meet the specification required at the target required as well.
Thank you. Anybody else got anything to add there?
Yeah, I'm just thinking that really, when it comes back to selecting the product, it's based on scale. So what's the scale of the repair, and then understanding what product fits where. So what's the right product for this repair? What's the right product for this type of road? What's the right product for this utility contractor to be using, in an urban area, for example, and maybe the repairs that are being done at night. How can we reduce noise impact and that sort of thing? So definitely, it's around scale and understanding what is the right product, and the education piece of things where we need help as an industry.
I think that brings question one nicely to a close then, gentlemen. So if we move on to question two, does SROH suppress or enhance innovation within the highways repair industry? And Karl, I think you're in a good place to start on this one.
Well, thank you very much. So the SROH, specification for openings in the highway, repair of openings in the highway. So if we're talking about cold materials, which we are talking about here, mostly innovation. So how do you get a new material into the specification? How do you manage to get it accepted? So there's a couple of routes in. You can automatically have a material accepted through a product acceptance scheme certificate. So why would you need to do that? Well, the SROH has a massive list under A2 at the back of it of all the types of materials that can be used or should be used within the specification. It doesn't really go into the cold glaze because they're not traditionally the bulk made materials. So it falls under the Products Acceptance Scheme Certificate, which in its former life was, most people understand it as HAPAS. So if you have that certificate, you can bring a product into use and it can be used immediately within the highway. The only caveat with that is that there are restrictions on cold lay materials, so it can only be used in type 3 and 4 roads. Whether or not you could then adapt your product acceptance scheme certificate maybe to get it into a high class road, it's possible. The other route is A9. So this is A9 approvals. So you team up with a council, you can put some of your materials into the road, you can speak to them, you can run through a process. Traditionally, that used to take, under the old SRH, it used to take 2 years, which is quite a long time for somebody to put money into a project and not be able to sell it. You can use it as binder course during that period, but not many people are going to buy just cold lay for binder course. It is difficult. You can do it. There is now an accelerated route through that, so you can work with the council and accelerate that by doing laboratory testing or through university or something, because road materials are, easily tested in a laboratory. But even when you have the A9 approval, it doesn't necessarily mean that all highways and councils will accept it, even though it's been through the full program of testing. So it is, the SRH isn't brilliant. They have tried to address it in the latest edition to try to accelerate that and to do it, but it is still quite difficult.
Appreciate that. Now I think if we move to Barry and ask, are we enhancing or are we suppressing?
Okay, well let's deal with a bigger question then. The SROH, does it enhance or suppress innovation? And we've just heard from Karl there that actually, if it's done correctly, innovation can be introduced very quickly to within the SROH. That's a little word, but there's a big meaning. It's if. Is industry actually prepared to structure itself to introduce changes to what is effectively legislation that has been issued for their own guidance? Well, most of our time we spend the debate around what does effective guidance mean to our sector. So the SROH, as Karl's just explained, is split into two parts. So it provides prescriptive guidance, this is how you shall do something, and then performance-led guidance, this is what we wanted to achieve and that's the outcome we would like. That's where the confusion sits, because the document takes an awful long time to introduce changes into the market. We do have trials, we do have product assurance schemes, they're out there, they're proven, companies know how they're used, and if you've gone through the pain of actually getting your products onto the market through an acceptance scheme, you should be able to sit back, rest assured that these products will be adopted by all authorities that require to use them or need them. It's not always true. It doesn't always happen. I've come from a background where I've written the documents that are used across the whole of the UK. That includes Scotland, Wales and Northern Ireland, and have been adopted by Europe. A lot of the guidance that's within those document sets is replicated within the SROH. But because the SROH is not updated as regularly, the information within that document set can sometimes be a little outdated. Confusion. If we then look at actually how that document is being used and does it work for our industry, I'd ask us to challenge the concept of the soft targets that contractors are now being asked to achieve, particularly when it comes to sustainability and the reduction of carbon within all of our materials. Does SROH allow you to introduce those concepts? I'm afraid the jury is out on that one. It's not proven. Is it, again, when we look at small repairs and we introduce safety into that environment, does SROH allow the industry to make choices to or how they will apply safe working practices to meet the key performance targets that the client has issued forward? Because we've heard from Hassan and Karl about the hot and warm mixes and the limitations that they have. Its scale of repairs, its repeat journeys backwards and forwards to ensure that you've got the right temperatures in your machines and that you can't use materials that fall below 130 degrees. So for us, it's those targets that would dictate our choice.
Cool. We'll stop you there and we'll just come on to Russell. Which camp is your foot in? Enhance, suppress.
Thanks very much. So, repairing roads the right way has been the sort of strapline for this event today. And the SROH is a document which does help, or it prescribes repairing roads the right way. But if you look at the background to the document, so why was the document introduced? So the document was introduced to hold utility contractors to account back in the 1990s. Local authorities were challenged whereby they had a lot of utility work being done and the reinstatements weren't being done at a consistent quality. So therefore that was the background to the introduction of the SRH. We're now on to version 4 and typically versions take up to 10 years to develop. And my view is 10 years to develop the next version is too long. 10 years from now, we're going to have, we'll have autonomous vehicles running around, all kinds of things can develop in the next 10 years. Things are moving forward fast. We haven't got 10 years to wait for version 5 of the SROH. So is there a way to embrace innovation within that document? As Karl explained, there are ways around it. Does the industry understand that? I would say no. And is it complicated for industry and local authorities to embrace and understand the content within the document? And the answer is yes. So it's the industry don't fully understand, so therefore they'll play safe and stick with what they know. And for the asset owner, there's a lack of understanding there too. So it really does restrict and defer the embracement of innovation because there's a greater piece here that we need understanding. So we need to have versions coming out every 2 years and we need to have a better awareness of how we can bring the innovation in and minimise the risk to the utility contractor and so they can embrace and engage.
Thank you. Hassan, last but not least.
Yeah, thank you very much. I believe if the teams, the R&D, does the research and development at the industrial sectors as well as in university research center, take the guidance and the principles within the SROH and develop their material, the new innovation or invention material, to make sure that they will perform within the restriction required for the reinstatement. That means the size of the reinstatement, the condition, the loading, you name it. That will be absolutely very positive to use the SROH as a guide. As SROH guidance is not only for the company who are instructing the material. In fact, it's for the road engineer as well as a follow-up on checking the material itself. However, I completely support what Russell mentioned, that if we come with a new innovation, a new invented material, there must be a way of using these material by inviting the policymakers, for example, the people from the SROH and the industrial to come together into a meeting and agree for express a quick way, of using these innovations. Thank you.
Thank you. I appreciate all your thoughts, gentlemen. So if we move into debate number 2, I guess if I can throw out there, a few people have mentioned the SROH being quite prescriptive. What do we do if we've got a product that performs, doesn't meet the SROH legislation? Can I ask why it matters? If we've got the right answer, why can't we go ahead and play with it? Karl, do you want to start with that one?
Yeah. So the difficulty that we have is that, as it was pointed out before by Barry, that the SROH is a legal document. And it's also prescriptive and performance based. So it's quite easy to have a material which on face of it performs, so that there's a part specification for S2 that gives you performance requirements, how much it can sink, how much it can crown, whether the edges are, how big the crack at the edge, if there is one, is all of that can be measured, and it's quite simple. A visual measurement, you can measure it with gauges, but it could also fail the construction side. So you could core it, you could test it, and it could fail. So it could be performing perfectly, and it could perform perfectly for 8 years, but it could then actually fail on the other side. And because it is a legal requirement that all parts of it are met, it does make it more complicated. It shouldn't be so difficult if it is performing and it's outperforming that's around it. However, that's the way that the specification is written. We can't get around that. It is a legal requirement.
And bringing it back to something Russell said earlier, then is the only way around that to have a more frequently updated version?
Yeah, so I think we had some suggestions put forward. Well, why can't the document be live? And my example here is we got an ERP system in our business, and we get a live update every quarter. And within that live update, you get an update in performance and criteria, and you may get some add-on plugins, etc., for that ERP system. Is there any reason why we can't have that kind of level of engagement with a document such as SRH, so that as the innovation comes and it's proven by the likes of John Moore's University and out on road trials, etc., why can't it be embraced very, very quickly and updated? As we said, bring the panel together.
There was a plan to have a live document. The part of the problem is that it's not a professional body of people that write the SRH. It's volunteers. It's people who are already working in industry who, in their spare time, work on the document. Now, some companies are very generous and they give people quite a bit of time to do it. Others less so, and it is time consuming. And so as an expert practitioners group, we look at stuff, we write responses to questions, and we then pass that up to the main group, and the main group then have to decide how they're going to put that, whether they're going to put it in or whether they're not going to put it in, and everybody has an opinion, and it is a difficult thing because you've got all the highways with all their knowledge and all their criteria, and you've got the utilities, but the utilities isn't a single thing. You've got stuff from telecoms which are relatively shallow, very fast moving, to water industry where you've got 2 metre sewers going in 5 metres down in a road. Completely different types of operations and working, and it is a complex thing, and it is people. The time it takes is immense, and they're not paid to do it. It's not part of their job, and they have brought in engineers to look at this to help with it, but they have a specialism as well. So the big engineers from big companies tend to do big projects. They're not looking at a 0.15 reinstatement around a telegraph pole, but that is part of what we have to deal with within.
And I think I could jump in here in bit of support, is that actually the industry itself is constrained. If you look at the SROH, we've identified that you can either have prescriptive or performance-led. You can't necessarily achieve the same result if you measured by those two at the same time. So as far as we are concerned within the industry, and actually those that are applying the technical documentation sets under contract, they have to be clear, is it either going to be performance-led, and therefore the material choice has to meet those performance characteristics, or is it performance-led, and the choices have to meet the objectives and the performance indicators that the client has stipulated under contract. One or other, not both.
It's good stuff.
Can I just add to this one? I think, the people who are leading the SROH and also the people who are making the policy, I think they need to take into account that basically if you are trying to judge the reinstatement material on their mechanical properties and the void content, for example, you will find if you have a 3 licensed testing center, they will give you different result. And that different result could have a variation of about 5% on the void, for example. So therefore I will suggest that if the reinstatement is really working perfect, there must be some statement in the SROH. It's not to fail these material, in fact to allow it and see the future performance of the material itself. So for example, in our lab, I'm doing some tests, and you will find that because of the road itself, the surface is not perfectly, you notice this crown, like this one here. If you take the sample from the middle, it will give you a result. If you go a little bit away from this, they will give you different result. And therefore I think the people should really take this into account into the judgment of the quality of the reinstated materials.
That's a good point. So if we move on to question 3, coming back to the hot or cold debate, can net carbon savings only be achieved with cold applied solutions? We'll start with you this time, Russell.
Yeah, no, thank you.
Is it cold only?
So I think the key point here to understand is that to achieve net zero carbon for construction of highways and repair and reinstatement of highways is an extremely hard thing to do. And with the technology we have on hand at the moment. Can it only be achieved with cold applied systems? I am looking to the other panelists to have their views on this one, but it's going to be a really, really hard thing to do when you're using energy to heat materials, unless you can find ways of, there are effective offsetting, carbon offsetting and that kind of thing, but introducing warm mix asphalt to that and those technologies certainly have a big part to play here. But I think for me, the bigger thing to consider is doing it the right way the first time. So let's take ironworks as an example. Ironworks is a challenge across the network, across the country, and reoccurring ironwork failures. Now, if you can reinstate that ironwork, do the repair the right way the first time, and you don't have to go back and redo that after 6, 8, 12 months, that has a huge impact on reducing carbon emission. One of the biggest factors that's contributing currently within the industry to carbon emission is going back and redoing reinstatements that have been done previously. So that's my view on that one. Back to you.
Karl, we'll move over to you.
So again, I think net zero, cold lay, scale definitely has a role to play in this. We're not at the point where cold lay is readily available at really large scale. And I agree 100%, right first time. As I said before, you might want to use something a little bit special or a little bit more expensive because you're in a really high stress area. use something that's a bit, whole life cost in environmental terms and monetary terms can be reduced by using something slightly more expensive or slightly different. There are things, so net zero, very, very difficult with hot mixed materials. There are things that people are doing, so that there's a lot of work going on to increase the amount of RAP, which is the waste planings from materials which go back into the mixes. There's a reduction of polymers by using other waste materials. So, for instance, rubber can be used as a polymer within the mix. It helps with longevity and produces a really good material and reduces the carbon footprint of the material. Other people have had a go with plastic beads to add some waste into it. As far as I know, it doesn't really enhance the performance, but it does get rid of a couple of kilograms of plastic. All these things are things that help to reduce it, but not necessarily to zero. And even cold wave will struggle with zero because we've got to get the raw materials to start with. The whole concept of zero is a very, very difficult thing within highway construction. But we can massively reduce, and that's what we need to do. Do it right, reduce the amount of times that things need to be replaced, and that will definitely have an improvement. No?
Thank you. I'll stay this side with Hassan for his thoughts on that.
Basically, getting zero carbon saving this can be achieved with cold mix asphalt. If you are talking about warm mix asphalt or other technology which is using heat, then you are not really achieving the zero carbon. Especially with reinstatement, because of the limited size. I think the technology is now really advanced very well by producing new materials, which is with no heat required, and they are meeting the specification. When I said meeting the specification, I basically support what Russell mentioned, do it right from the beginning. So if the construction of the site is being done correctly, if the material selected and checked at the laboratory and being proven absolutely correctly, then the idea of using cold mix asphalt is the best way. The problem with the cold mix asphalt is the cost, and at Liverpool John Moores University we are using some sort of material which is completely negative cost effective. So we are using some ash, and that's the material which normally go to the landfills, and we are developing this material further to further bond the cold mix in addition to the emulsion. So we have the emulsion bonding as well as the other material which is hydrated, and it's giving us a material basically to reach to the requirement. We have a trial in a black barrel. The life of this one is approximately 6 months. It's performing absolutely very, very well. Many thanks to the Creek. They are really helping us to another trial, which is going to be in Liverpool. So the technology we developed and the technology available, I think with further innovation, the innovation will never stop. The invention will never stop. The development, always, going forward. So yes, I'm very optimistic that we can achieve zero carbon by using cold mix asphalt.
Thank you. All right, cold only for net zero.
Right, can carbon net zero targets be achieved with cold applied solutions? But the answer to that, I think we've heard, is no. It's not the only solution. There are other methods that can be applied. I think the key requirement this industry needs is to understand what they are having to achieve. So are we looking at the cost of our practices today that will be held by our future generations? So are we doing things that actually are, we would consider a little risque? Think of the Victorians and their sort of coal-fired chimneys. Yes, the money that the country generated allowed it to be a world power, but we are picking up that banner now and fighting the costs of sort of the reduced ozone layers. The targets that we in UK have actually signed up to are now 10 years old. There's been no agreement actually on what we should be doing and how we should be tackling things. There's still debate on whether we are able to apply certain materials. I think we heard from Hassan and Karl about the need for more research, more development, that will then help us to introduce more products to the market in a quicker fashion. At the moment, we ask for not just research and development, but on these proven materials, we then insist on trials. And it can be 3 or 4 years before these products are actually introduced to the marketplace for no good reason. If we ask for performance-led materials to be used on certain types of road, then we've got a greater certainty that these materials will benefit future generations, because that performance can be measured. The non-permanent repairs, we heard about reinstatements not being allowed on type 1 and 2 roads. Well, actually, reinstatement work is already considered non-permanent if you look at the life of the asset. It's only under contract where they say that the asset has to be returned to its original performance state. Actually, the asset itself could be a number of years old. So are you then writing in through contract a performance level that is not necessarily appropriate? If we look at actually how CO2 calculations are then divided and applied, we've got methods, and it was mentioned earlier about offset. So is carbon offset an acceptable approach when it comes to future generations? It's certainly the approach that's been applied now, but we can look at alternative methods, and the benefits that we said about coal materials are actually numerous when it comes down to looking at safety, looking at the reduction of repeat visits, looking at the need to set up a lot of sort of traffic management, particularly when it comes to Chapter 8 installations.
I think if we can just stop there for now and we move into debate on this question, because a few people have sort of mentioned getting the right solution first time. If that's what it's all about, and we've got hot and cold viable solutions, how do we determine which application is right to use in order to try and get it right first time? And if that's then cold solutions, and the problem of that, as you mentioned, is cost, what amount of cost doesn't justify using it, even if it's the right solution?
Okay, so I'll start.
Push that one away nicely there.
So cold materials have different price bases. The difference with the newer, the MMA type cold lay repairs is that they're flowable. So much in the same way that with hot materials, there are some flowables. So if you go towards the mastic end, which are much more expensive than the regular tarmac at the bottom end. Both of those solutions, depending on scale, gives you the ability to reinstate without the need for compaction. And if you don't need to compact, you don't need to cut open a reinstatement to get a compaction. So minimum size of a mechanical compactor plus 30 mil to give you a bit of leeway to damage the edges. Can we, it's keyhole cylindry for the road. Can we do things better? Can we, when we're removing ironwork, do we have to cut back so big? Well, not really. the chamber's there. If the existing road is okay and it's an issue with the chamber, we don't need to cut back because we're not having to compact at a lower level. We can use products, flowable products at lower levels. We can use flowable cold lays or non-compacted cold lays that don't need, you don't need to have compaction equipment. You can speed up that process, which is, you can use less. Okay, the materials might be considered to be slightly less carbon neutral. However, if you're using less of them, you're massively reducing the impact that you're having on the environment. And it's that moving forward, thinking about doing things differently. We've always done it the same way. Let's do things differently. And that's
Can I just add to this one? Yes, I support this opinion, but compatibility is very, very important. Sometimes you do a reinstatement and the material you are using is stronger than the surrounding, and that will cause a lot of troubles, because of the flexibility while the tiles, moving on them. You will find the material stronger than the other one. So it's not, the material itself is really providing all the acceptance. It's the compatibility as well as the how the joint is being done between the two of them. So that's a very, very critical one. So therefore, testing and also allowing some trials before using the new innovation is important for the economy, for the safety, and also for the length of the lifespan of the road.
we'll just come back on that very, very briefly. So the ironwork in the road, which is what we're sort of alluding to here, it's a solid immovable object in a flexible road. The interface between that solid immovable object and the flexible road is always going to be an issue. That's where the better quality materials that interface better and give you a better performance. Obviously, if they are impervious to water as well, so materials that have air voids aren't impervious to water, they're going to have some voids in them. It's a better way, and probably over to you. You're the expert with the cold line.
Just really coming back to Matt was emphasising the subject of costs earlier, and I think really if we're going to take this net zero carbon subject seriously, we have to accept that somewhere along the line there's going to be some cost. Now, it doesn't necessarily have to be that the whole life cost is increased, but front end increase in cost, most likely yes. And how do you decide whether you can or can't afford it? Well, you need to decide whether you do or don't want to achieve net zero carbon.
Fair point well made.
I'd add to that as well. But, when we're talking about scale of repairs, I'm not in this instance talking about size, I'm talking about sheer numbers. So local authorities are hamstrung really by the scale of their maintenance requirements. So for them, it's not just about housekeeping, it's understanding what has to be done and why, where and why. So they spend an inordinate amount of time looking at the repair programs, looking at the maintenance sort of overheads that go with those. The real concern from within industry, and certainly from my perspective, is that if they're having to repair one item within the guarantee period, the chances are that everything else that was installed on that stretch of the network is probably suspect as well. But at that moment in time, they'll focus on the one repair, and then they will repeat visits. And my concern is that actually there's no repair for prevention. And the thinking at the highest levels has got to be about preventative measures if they're going to achieve these targets against sustainability and CO2 reductions.
Thank you. Okay, last question on the floor. Does product certification remove the risk for the asset owner adopting a new product? We'll start with you, Barry, actually.
Okay, well, Matt, thank you very much. A statement was made not 5 minutes ago, actually, about our industry and those that are employed within the reinstatement of ironworks in particular, but also the fields that we undertake when it comes to openings in highways. And it was industry looking at it and saying, why do we need to change? We have always done it this way. And from personal experience, I have been called to site to look inside an opening because the reinstatements were failing on a regular basis, and we were being asked to finance a scheme to remove that piece of ironwork from the carriageway and stick it in the verge. The actual practice is, when you looked at the hole, you saw all end of materials that were being used to hold up what was ironwork that was in a trafficked area where HGVs were constantly moving. We're talking coke cans, we've got telephone directories, we've got inappropriate class of brick. The materials weren't even bonded. There was nothing inside that hole that actually met with any of the technical guidance that we have debated throughout today. And it was repeatedly failing, and the contractor was repeatedly coming to site to do the repair. The conclusion there is the repairs were always being botched. Now, that's not a fair assessment of my industry. It might be an assessment of a couple of rogues, but that is not my industry. So when I talk about product certification, will it remove the risk? Then certifications in their own right do not remove risk. Certifications give you confidence that that system has been applied appropriately in the laboratory and under test conditions. The only way you as a client are going to negate the risk is by taking action yourself. That means that you undertake a series of assessments, whether it's coring of the materials that have been installed at an agreed period of time before you adopt that installation. A simpler way will be to ask for method statements at the front of the installation. So not just give it over to your primary contractor and say, please go and do a repair. Tell me what you're going to do and how you're going to do it. Let me make an assessment. That means that they are also helping you understand what the technical requirements are. As-built evidence. Let's start asking for as-built evidence. That's your drawings. That means that assessment of any new product can be achieved at the source.
We'll stay over here with you, Russell. Does certification take risk away?
Well, let's start looking at certification itself. So product certification, in my view, is an excellent thing in principle. But I'd also argue the fact that having a declaration of performance for a product that has been tested and could have been tested by multiple different agencies across the country, which can include universities and others, is also as meaningful when it comes to the actual product performance as a test certification. But I think the bigger thing here is you can have a certified product, and as Barry's been explaining, you can have a certified product, you can have a certified group of products, and they've been put into the road, but they put into the road the wrong way, and they will not perform. And so does that remove the risk for the asset owner? Not. What we need to be focusing on here is ensuring that the installers are trained. And we're just the venue we've got here. So we're with Fareham College. They've got a highways academy called CTEC. So this is a perfect platform where we can embrace new innovation. We can help to train the new cohorts that are coming into the industry. So they know how to do the job the right way the first time, we talked about earlier. And that is how we're going to minimise the risk to asset owners. So yes, you have a whole selection of great products. They're all great performing products. Some might be certified, some might have declaration of performance. Bring them all together with an expert installation team and you've got a great fix. That's my points today.
Hassan?
Yeah, I support what Russell mentioned in this one. It's absolutely great, to have a certification for our products, and especially if this one comes in a short time after, so if the invention, innovation, and the testing show a brilliant, material is coming, out, then as Russell, mentioned, the risk is on the execution. So whether you prepare the reinstatement site, to the requirement, also the surrounding, material around it. So I would suggest not only the certification of the product, I think, the installation and the way the people, they come back, and monitor the construction is extremely important to make sure that the product will perform as the people who certified this approve that it should be. Thank you.
Final say to you, Karl.
Thank you. So, product certification, brilliant. It tells you what can be achieved in the laboratory on that day or monitored on site. Very, very small sample of it. What I think is equally important is a really, really well-written installation methods statement that goes with your product. Your product, you know your product better than anybody, and a good installation methods statement you will be able to write into that exactly how you want it installed, what circumstances, what conditions, what depths. You can vary the depths outside the SRH as long as it's part of your certificate. You can say, actually this material performs better if we do it at this, and it's really good. And you've got to have that. It's got to be detailed. It's got to be understandable for guys on the ground. So, cut out the flowery language. This is an installation method statement. Pictures are great in installation method statements. And training. So Russell alluded to this before. If you've got a product that's a high quality, high value product, insist that you do training with the guys to install it. And therefore, you've got better stuff. Just very quickly, why most utilities, not all councils, but we have a system that we follow now. So the guys turn up on site, they have to photograph the site before they start work, they photograph the site during work, and it's a really good way of having a reinstatement method statement in effect, but catalogued and recorded against that specific job. So if something does happen with that job in the future, you can look back and say, well, why was that? Well, it was -3 and it was snowing heavily. Probably wasn't, was that was that allowed at the time? So basic stuff, but trying to join it all together.
So from the answer that everybody's given, do we think there's too much emphasis on and maybe too much interest in getting a product certified over that same amount of emphasis and energy into teams within businesses to implement these products correctly?
Yeah, so one thing I'd like to maybe bounce off Karl here is if you've got a product that is certified, and as you've alluded to there, it's going to go through those lab tests. You're going to do a series of lab tests, and then you're going to go and take it out and do one very small trial on the highway. Whereas you might have a declaration of performance which will go through exactly the same lab tests, and it will have multiple road trials, but it won't be maybe not under the same test conditions and under prescribed periods. For a utilities contract, is there any risk in taking a product that hasn't gone through that sort of prescribed 6 months small test patch to get a certificate, but it does have all the declaration of performance that says it will perform, bang, bang, bang?
So, product acceptance scheme certificates, I've actually sat in a group that has reviewed some of the products that have gone in, and depending on who does the process, they are asking, have you got 2 years of your material being in the ground? So you may have done some development work, you've worked with a local council, and it's really important you can go back to that, take a core out of it, you can show it's actually your material. And that's the thing about sort of the A9 thing. It used to be 2 years, and it was really frustrating for producers because there was no money coming in because they couldn't sell anything for 2 years. But there is accelerated ways of doing this now through lab testing. So it's not a straightforward answer, I'm afraid, but the product acceptance scheme certificate, as with HAPAS, it won't be on a single thing. It will be over a period of time, and it will be backed up by laboratory testing.
Yeah, so I think the point maybe here is to having local authorities that will engage and enable products to be tested. So we've got that sort of catalogue of test sites, 6 months, 12 months, 24 months, etc. helps to accelerate.
Yeah. Test sites in your car park aren't that much value. They've got to be out there in real life and monitored, and you've got to accept that if something goes wrong, we'll solve it.
Can I add just to this one? We are lucky in a country whereby the environment is a little bit different in the north, in the middle, and the south. And equally worldwide, you have hot countries, you have cold countries, and you have, the loading on the road itself. I think, any trial is limited to one location, one council is not enough really to produce, the certification for the material, in addition to the certification of the implementation and the construction of the material and the monitoring of the material for a long time. So I will recommend it that for any certification need to cover all the criteria, all the environmental conditions expected during the life times of using these materials as reinstatements.
Thank you for that. The issue here, it's about risk. So we work in an industry that is risk averse. There is an element of risk in living, I appreciate that, and actually, as far as our industry is concerned, we have made huge leaps in making the working environment a safe place to be. So it's methods that have been employed, it's behaviours that have been changed, and we would then turn around and champion that position from the construction industry. When it comes down to materials and what we are doing with our materials, well, we know that we don't use hazardous materials, or we minimise the use of those in certain environments. But we do not then change our behaviour to actually look at what is the appropriateness for use of materials in certain circumstances. Our contracts, for instance, refer back to products assurance or certifications that will take a number of years to actually achieve. And in that period of time, we'll continue doing things in the old methods because that's how we have always done it. We know it's tried and tested. Actually, in truth, those methods have never been properly tested from a particular environment. Hassan's just alluded to that. Different parts of the country have different requirements depending on the seasons. So for myself, product assurance gives me an idea that actually a product is working, and I can look at it and I can judge it. But it doesn't tell me whether that's the most appropriate product to be used in that certain circumstances. And there are products out there that are being introduced today that will give me certainty for the future, and maybe I should take that little level of risk. Adopt, as Karl said there, the method statements, the analysis, the research and development work that's gone behind it, and agree that that is suitable for my assets.
Thank you very much.
Just one comment, to add to this one, that the crew who are going, to concentrate and complete, the reinstatement needs to be trained.
Okay, we'll end that there. Thanks to our panellists, Karl, Hassan, Russell, Barry, and thanks to Fareham College for hosting us today. A really good debate, really good discussion, lots of insight, and it seems that we've got an industry that's very focused on a more sustainable future. It seems we can't do this alone, and it's debates and conversations like this where we challenge ideas and sort of swap thoughts that are going to lead us to the right path for future innovation. So, thank you again. Thanks for having me. Thanks for Meon.
Thanks, Matt.
Appreciate it.